All right, let's go ahead and balance some redox reactions using what we call the half reaction method. So we're going to use the half reaction method for balancing redox reactions. So essentially what we have to do, we have to determine what gets oxidized, what gets reduced, write the half reactions, then balance elements that are not hydrogen and oxygen, which is typical for balancing. Then we balance oxygen with water. That's different. Balance hydrogen with H plus, and this is under acidic conditions. We're going to balance under both acidic and basic conditions. We balance charge with the electrons, and then we may need to multiply the reactions by a coefficient in order to get the electrons lost to equal the electrons gained. You can't have different numbers of electrons leaving and or oxidizing and then reducing. All right, so let's go ahead and get the show on the road here. So here are two reactions. We're going to balance these in, as you can see, acidic solution. All right. And so here we go. Here's our first one. The first thing that we're going to want to do, I know it says write the half reactions, but you can't write the half reactions unless you know what gets oxidized and what gets reduced. So we've got to figure that out. So here we go. So the way we figure out the oxidation states is the most electronegative atom is going to get its charge. In this case, that's oxygen. There's three of them. So that's 3 times a -2, which is -6. That gives us a +6 over here. But there's 2 arsenics. So we split that +6 up, and arsenic is +3. Over here, oxygen gets its charge at -2, 3 times the -2, again, -6. But the charges have to add up to -1 because this is nitrate anion with a -1 charge. So that's got to be a +5. Okay, so that's a +5 right there. Over here, we can go ahead and start with hydrogen because we know that it has a +1 charge in most compounds. I'm not going to give you any where it doesn't. So that's 3 times a +1, which is +3. Then oxygen is a -2. 4 times a -2 is -8. Everything has to add up to 0. So this has got to be +5. So arsenic is a +5. Over here, nitrogen monoxide, oxygen is -2. There's only one of them. So this is going to be a +2 charge. Now let's see what got oxidized and what got reduced. The way you figure this out, and remember that anything that gets oxidized or reduced is happening on the reactant side. What we're going to do is we're going to use the product side to see what got oxidized and what got reduced on the reactant side. Let's start with the arsenic, which is +3, and it's going from +3 to +5. +5 is a higher oxidation state than +3 is, so electrons were lost. And so we'll say this is the oxidation half reaction. For the nitrate, it goes from a +5 to a +2. +2 is a lower oxidation state than +5, so it was reduced. Now remember, everything's happening over here on the reactant side. We just use the product side to tell what happened on the reactant side. So never choose what got oxidized or reduced from the product side. Okay, now we have written both the oxidation and reduction half reactions. We split up the reaction into half reactions, oxidation and reduction. Now that we've done that, we're going to balance all the elements that are not hydrogen and oxygen. Well, that's arsenic. That's really all we've got. So we've got 2 arsenics on the reactant side, only 1 arsenic on the product side. So I'm going to change the coefficient to 2. We balance oxygen by adding water to the side that's deficient in oxygen. I have 3 oxygens on the reactant side. I have 2 times 4, which is 8 oxygens on the product side. And so in order to get 8 oxygens on the reactant side, I have to add 5 water molecules, H2O. All right, that gives me 5 oxygens plus 3, that's 8. 2 times 4 is 8. But now I've added 5 times 2, 10 hydrogens. The way we balance hydrogen in acidic conditions is we add H plus to the side that's deficient in hydrogen. Now I already have 2 times 3, which is 6 hydrogens. So all I have to add are 4 H pluses over here. Now that I've balanced hydrogen, oxygen, and arsenic, I balance charge. There is no charge on the reactant side, but there's a 4 plus charge over here on the product side, and I balance charge by adding electrons to the side with the most positive charge. Now, as a matter of fact, if it's an oxidation half reaction, the electrons will always be added to the product side. So oxidation half reactions, electrons are being lost, so the electrons will go on the product side. But we just neutralize charge by adding 4 electrons to the 4H pluses. All right, on to the reduction half reaction. We've got 1 nitrogen, 1 nitrogen. So nitrogen's happy. 3 oxygens on the reactant side, so we're going to need to add 2 waters over here to get our 3 oxygens. 2 times 1 is 2, plus 1 is 3. But that gave us 4 hydrogens, so we need to add 4 H pluses over here to balance hydrogen. All right, we've done that. Now we're going to add electrons to get the electrons balanced. Well, I've got 0 charge over here on the product side of the reduction half reaction. I've got a 4 plus and a minus 1. That's a 3 plus net. I need to get it down to 0, so I'm going to add 3 electrons. Okay, I've now added 3 electrons to the reactant side of the reduction half reaction. And that's the other thing. When you are doing the reduction half reaction, the electrons will always go on the reactant side because that's what reduction means. You're adding negative charge, reducing the positive oxidation states. All right, so here we go. All right, now that I've got the 2 half reactions balanced, I need to get the number of electrons lost to equal the number of electrons gained. And the way I do that is if I have 4 electrons being lost here, 3 electrons being gained here, I need to multiply this entire reaction by 3 and this entire reaction by 4. That'll get me 3 times 4, which is 12 electrons lost. 4 times 3, that's 12 electrons gained. So I'm going to go ahead and I'm going to multiply these coefficients by those values, and we'll get right back in there. Okay, now that I have multiplied all the coefficients by the multipliers I determined to get the number of electrons the same lost as gained, we now have 12 electrons lost in the oxidation, 12 electrons gained in the reduction. We can go ahead and cancel those electrons. All we used them for was to make sure that charge was balanced and that we were losing and gaining the same number of electrons. We can also cancel some other things. So for instance, I've got 15 waters over here on the reactant side of the oxidation half, and I've got 8 waters on the product side of the reduction half. So before I add, I can cancel 8 waters. That's going to give me 7 waters over here on the reactant side of the oxidation half. I've also got 12 hydrogen ions. I can go ahead and cancel 12 of those, 12 of the 16. That gives me 4 H pluses remaining once I cancel 12 of those. Okay, there's nothing else I can cancel, so I'm going to go ahead and add the 2 half reactions. Okay, I have added the 2 half reactions together after canceling the electrons, some water, and some hydrogen ion. Let's make sure it's still balanced. 7 times 2 is 14 hydrogens plus 4, that's 18 hydrogens. 18 hydrogens on the reactant side. And over here on the product side, I've got 6 times 3, which is 18 hydrogens. We're good on hydrogen. 7 oxygens plus 4 times 3, that's 12. It's 19 plus 3 times 3, that's 9. So that's 28 on the reactant side. 6 times 4 is 24 plus 4, 28 oxygens. So nitrogen, I got 4 on the product side, 4 on the reactant side. There's no charge on the product side, and on the reactant side I have 4 pluses and 4H plus, 4 negatives for the 4 nitrates. They cancel each other. So this reaction is balanced under acidic conditions. How do I convert the acidic conditions to basic conditions? Well, you would add hydroxide. So we're going to add 4 hydroxides. That's base. That's going to give us 4 waters over here, H2O. If I add the 4 hydroxides to one side, you've got to add it to the other side as well. Gosh, I hope that's showing up. So that's 4 hydroxides on the product side as well. This is going to give me 4 more waters plus the 7, so I'll have a total of 11 H2Os here. These 4 hydroxides are gone, and now that I've accounted for these 4 waters, I have 7 plus 4. That's 11 waters plus 4 nitrates plus 3 AS2O3, and that gives me 6H3ASO4 plus 4 NOs, and then I've got my 4 plus my 4 OH minus. And so we are still balanced, but now we're balanced under basic conditions. All right, we've gone from acidic conditions with excess H plus to now basic conditions with excess hydroxide ion. So all you got to do is balance under basic conditions and then add hydroxide to the hydrogen ion added to both sides to balance under basic conditions. All right.